There are machines that help you build, and then there are machines that seem actively designed to kill you. From chain trenchers that act like giant subterranean chainsaws, to scrapers that bounce at 13 km/h with no suspension. This channel is a refuge for those who have hydraulic oil in their veins. If that's you, subscribe now and join our crew. This video isn't about efficiency. It is about the fear and respect these 10 mechanical monsters command. 1. Chain trenchers. When you visualize excavation, you likely picture a bucket scooping up dirt. However, when engineers need to cut narrow, deep channels through solid rock or highly compacted soil for pipelines and telecommunication networks, a bucket is inefficient. The solution is the chain trencher. Conceptually, this machine is terrifyingly simple. Imagine a chainsaw, but scale it up until it is the size of a semi-truck or larger. Companies like Vermeer and Ditch Witch manufacture these behemoths, which utilize a massive, heavy-duty metal chainsaw-like apparatus called a digging boom. This boom is wrapped in a continuous metal chain fitted with high-strength steel or tungsten carbide cutting teeth. When engaged, the chain rotates at high speeds, ripping into the ground with immense torque. The danger of the chain trencher is twofold: the mechanical hazard and the operational environment. Mechanically, the open nature of the digging mechanism is a severe risk. Unlike an excavator where the danger zone is largely defined by the swing of the arm, the trencher features exposed, rapidly moving teeth that can snag clothing or limbs in a fraction of a second. There is no glancing blow with a chain trencher. Contact with the digging chain is almost invariably fatal, or results in traumatic amputation. The momentum of the heavy chain means it cannot stop instantly, even if emergency kill switches are activated. Furthermore, the operational environment is perilous. These machines are designed to obliterate what is in front of them. If a trencher hits an uncharted utility line, such as a high-pressure gas main or a high-voltage underground cable, the result can be an immediate explosion or electrocution. The operator sits directly above or just behind this violence. Additionally, because the machine digs deep, vertical walled trenches, the ground immediately surrounding the machine can become unstable. There have been instances where the trench walls collapse due to the vibration of the machine itself, potentially causing the heavy machine to tip into the very ditch it is digging, trapping the operator. 2. Sideboom. Pipelayers. At a glance, the Sideboom pipelayer looks like a standard Caterpillar bulldozer that has been confusingly modified. It tracks like a dozer, but instead of a front blade doing the heavy work, it features a massive crane boom mounted on the side of the chassis. These machines are the backbone of the energy infrastructure, used to lift, transport, and lower miles of heavy steel piping into the ground. The Sideboom makes this list primarily due to physics, specifically the center of gravity. In almost all other lifting machinery, like standard cranes, the load is lifted somewhat centrally or balanced by a massive rear counterweight that keeps the center of gravity within the machine's footprint. The Sideboom, by design, lifts its load hanging off one side. To prevent the machine from tipping over sideways, it utilizes a movable counterweight on the opposite side. The operator acts as a balancing artist. As the boom extends out to lift a pipe, the operator must simultaneously extend the hydraulic counterweights on the other side to maintain equilibrium. If the load is heavier than anticipated, or if the operator swings the boom out too far without adjusting the counterweight, the machine will reach its tipping point instantly. The danger is compounded by the terrain. Pipelines are rarely laid on flat, paved surfaces. They traverse mountains, swamps, and steep inclines. A Sideboom carrying a 40-ton pipe on a 20-degree muddy slope is fighting a constant battle against gravity. If the machine tips, it creates a crush zone. Unlike a car rollover where a cage protects you, a Sideboom rollover is violent and often crushes the operator cabin, especially in older models without ROPS, rollover protective structures. Furthermore, pipelayers often work in convoys, where multiple machines hold a single continuous section of pipe. If one machine slips or tips, it transfers its load instantly to the adjacent machines, potentially causing a domino effect of tipping machinery that can wipe out an entire crew. 3. High-reach demolition. Excavators. Demolition is the art of reverse construction, and the high-reach excavator is the king of this domain. These are standard excavator bases fitted with disproportionately long multi-stage boom arms, sometimes reaching heights of over 90 meters, almost 300 feet. At the end of this slender arm sits a heavy hydraulic shear or crushing jaw, designed to chew through concrete and steel beams at the top of skyscrapers. The primary danger here is the zone of exclusion. When an operator is tearing down a building from the bottom up, gravity is managed. But high-reach excavators tear buildings down from the top while sitting on the ground. The operator is essentially inducing a controlled collapse directly above or slightly in front of their own position. While the cabs are reinforced with falling object protective structures, FOPs, and thick impact-resistant glass, they are not invincible. A miscalculation in how a structural beam is cut can cause large sections of masonry or steel to slide down the face of the building and crash onto the machine. Beyond falling debris, stability is a nightmare. The higher the arm goes, the higher the machine's center of gravity rises. When the tool is 20 stories in the air, even a slight movement of the tracks on the ground is amplified at the tip of the boom. Wind becomes a serious factor. A gust that wouldn't affect a normal excavator can rock a high-reach machine dangerously. Operators also suffer from sensory disconnection. They are performing precise surgical cuts on steel beams hundreds of feet away. While cameras assist them, the lack of depth perception and the delay in feeling the bite of the tool can lead to mistakes. If the heavy hydraulic tool gets stuck in the building's framework and the building shifts, the structure can pull the excavator over. The leverage exerted by a stuck tool at that height is enormous, easily capable of flipping a 100-ton machine on its side. 4. Scrapers. Moto scrapers. While most heavy equipment is defined by its raw lifting power or digging force, the wheel tractor scraper, often exemplified by giants like the twin-engine Caterpillar 657, is defined by speed and momentum. A scraper is essentially a heavy-duty wagon with a sharp bottom edge that slices the ground, filling a central bowl with tons of dirt, which it then transports to a dump site at high speeds. The primary danger of the scraper lies in its unique combination of massive weight and high velocity. Unlike a bulldozer that crawls at walking pace, a loaded scraper can weigh over 100 tons and travel at speeds exceeding 50 km/h, 30 km/h, over rough, uneven haul roads. This creates a terrifying kinetic energy equation. If a scraper loses braking power on a downhill grade, or if the operator loses control on a slippery turn, the machine becomes an unstoppable projectile. The stopping distance for a fully loaded scraper moving at top speed is significant, and unlike articulated trucks, they can be difficult to steer under heavy braking. However, the most insidious danger involves the operator's long-term health. Scrapers are notorious for a phenomenon known as loping. Due to the rhythmic distribution of weight and the lack of traditional suspension systems found in passenger vehicles, the machine can enter a harmonic bounce while traveling at speed. The operator, positioned directly over the front axle, is subjected to violent vertical forces. In the industry, older models were often grimly referred to as kidney busters. Before the invention of the cushion hitch, a hydraulic shock-absorbing connection between the tractor and the scraper bowl, the operator absorbed every impact. Even with modern dampening systems, the whole body vibration, WBV, experienced by scraper operators is among the highest in the construction sector. This repetitive trauma leads to a high incidence of chronic spinal injuries, compressed discs, and lower back pathology. The machine doesn't just threaten immediate accidents, it physically degrades the operator's skeletal structure over time. 5. Landfill compactors. The landfill compactor acts as the grim reaper of the waste management world. Based on the chassis of a wheel loader, these machines are modified for one specific purpose: to crush and compress refuse into the smallest possible volume to maximize landfill space. Instead of rubber tires, they roll on 4 massive steel drums studded with sharp cleated tips designed to shred and mash debris. The danger here is defined by the environment. A landfill is not a stable construction site. It is a biologically active, shifting mountain of unpredictable material. The ground beneath the machine is composed of trash, mattresses, appliances, organic sludge, and hollow containers. It is common for voids to exist beneath the surface layer. If a compactor drives over a weak spot, the ground can instantly give way, causing the heavy machine to list violently or tip over. Visibility is another critical hazard. These machines are often equipped with massive trash blades to push piles of refuse. Between the bulk of the machine, the height of the trash piles, and the dust or steam rising from decomposing waste, the operator's blind spots are substantial. In chaotic landfill environments where dump trucks, spotters, and sometimes scavengers are present, the risk of a compactor backing over a person or a smaller vehicle is a constant, lethal threat. Furthermore, the machine itself is a fire hazard. The friction of steel cleats against metal waste can create sparks. Combined with methane gas generated by decomposing trash and flammable materials like paper or chemicals, compactors often find themselves working in the middle of spontaneous surface fires. The operator is sitting on top of a fuel source, surrounded by fuel, in an environment that is biologically hazardous and structurally unsound. 6. Mobile rock crushers. While excavators and bulldozers shape the terrain, the mobile rock crusher, or aggregate crushing plant, is designed to consume it. These machines are essentially portable factories containing a massive feeder, a crushing chamber, jaw, cone, or impactor, and a discharge conveyor system. They are used on-site to reduce demolished concrete, asphalt, or blasted rock into reusable gravel. The sheer violence required to pulverize solid stone makes this machine one of the most unforgiving environments for a worker. The primary danger is the phenomenon of fly rock and material ejection. Inside the crushing chamber, massive steel jaws or rapidly spinning rotors strike the stone with immense force. Occasionally, instead of shattering downwards, a rock can be ejected upwards or sideways out of the hopper. Despite rubber curtains and safety guards, these projectiles can travel at lethal velocities, posing a severe risk to anyone standing on the service platforms or near the feed inlet. However, the most statistically deadly activity involves maintenance, specifically clearing blockages. It is common for rocks to form a bridge or arch in the jaw, stopping the flow. The temptation for operators is to clear this jam manually. If the potential energy of the jammed rocks is released suddenly, the material can shift violently, crushing the worker's tools or hands. Even more dangerous is the stored energy in the machine's massive flywheels. Even after the engine is cut, the heavy steel flywheels can continue to rotate silently for several minutes. If a worker attempts to service the belt or the crushing chamber before the machine has come to a zero-energy state, the mechanism can shear off limbs with zero resistance. Additionally, the rock crusher is a silent killer regarding long-term health. The process generates massive amounts of silica dust. Without rigorous water suppression systems, operators are exposed to respirable crystalline silica, which causes silicosis, an incurable hardening scarring of the lungs. Combined with noise levels that frequently exceed 100 decibels, comparable to a jet takeoff, the rock crusher attacks the operator's lungs and hearing just as aggressively as it attacks the stone. 7. Steam shovels. To understand the steam shovel, we must look back to the era of the Panama Canal and the early 20th century. Before the advent of hydraulic pistons and diesel engines, the world was moved by steam. Machines like the Marion or Bucyrus steam shovels were the titans of their day, but by modern safety standards, they were rolling death traps. The most catastrophic risk was inherent to its power source, the boiler. The operator and the fireman, the crew member responsible for feeding coal into the furnace, were literally sitting on top of a high-pressure bomb. In the early 1900s, metallurgy and safety valves were not as advanced as they are today. If the water level in the boiler dropped too low, exposing the crown sheet of the furnace, or if the pressure relief valve failed, the boiler could suffer a catastrophic explosion. This would unleash a blast of superheated steam and shrapnel, instantly scalding or killing the crew inside the cramped wooden or corrugated metal housing. Beyond the boiler, the mechanical operation was terrifyingly exposed. Unlike modern machines where moving parts are encased, a steam shovel was a web of exposed gears, spinning flywheels and tensioned cables. The crowd mechanism, which pushed the dipper stick out, and the hoist mechanism relied on massive chains and winches that were often open to the air. A slip on the oily wooden floor could send a crew member falling directly into gnashing steel gears. Furthermore, the operation was physically brutal. There were no joysticks. The operator managed the machine using heavy levers and foot pedals that mechanically engaged clutches and brakes. These controls required significant physical strength to operate and often had a kickback. If a lever snapped back due to a mechanical bind, it could break the operator's arm or jaw. The braking systems were also rudimentary. If a heavy load caused the main hoist brake to slip, the bucket could free fall, smashing into the pitmen working below. 8. Forestry mulchers. The forestry mulcher represents the ultimate evolution of land clearing efficiency, and consequently, a unique profile of danger. These machines, often based on high-horsepower compact track loaders or dedicated forestry carriers, are equipped with a front-mounted drum that spins at upwards of 2,000 to 2,500 RPM. This drum is covered in fixed-tooth carbide cutters or swinging hammers. The goal is to drive directly into standing trees and dense brush, reducing them to wood chips in seconds. The terrifying aspect of the forestry mulcher is the missile hazard. The spinning rotor acts essentially as a baseball pitching machine on steroids. When the teeth strike a tree, the wood is shredded. However, these machines often work in neglected areas where hidden hazards like discarded fencing wire, iron posts, large rocks, or concrete chunks are hidden in the undergrowth. When the high-speed rotor impacts a rock or a piece of metal, it doesn't just chip it, it launches it. These debris objects can be thrown hundreds of feet at bullet-like speeds. While the operator is protected by thick, bullet-resistant polycarbonate windows, standard glass would shatter instantly. The danger to the surroundings is immense. A thrown rock can easily penetrate the cabin of a nearby support vehicle or kill a bystander instantly. This requires a massive danger zone around the machine, often 300 feet or more, which is difficult to enforce in dense manufacturing areas. For the operator, the danger also comes from intrusion. In heavy brush, the machine is constantly pushing over trees. A dead tree or a widowmaker, a broken branch hanging in the canopy, can fall onto the cab. While ROPS, rollover protective structures, are standard, a sharp, heavy branch can occasionally spear through the protective grating or enter through the gaps in the machine's armor, impaling the cab space. Additionally, the mulching of dry wood creates a localized cloud of fine, flammable dust. It is not uncommon for forestry mulchers to catch fire due to the accumulation of this dust on the hot engine and hydraulic components, forcing the operator to escape a burning machine in the middle of a dense, fuel-rich forest. 9. Sheep's foot rollers. Antique toed models. Compaction is a critical step in construction, ensuring that soil does not settle under the weight of a building or road. Modern compactors are self-propelled, sophisticated machines with integrated braking systems and rollover protection. However, the ancestor of these machines, the toed sheep's foot roller, earned a fearsome reputation in the early and mid-20th century. The machine consists of a heavy steel drum covered in rectangular steel lugs or feet, resembling the hoof of a sheep. These feet are designed to penetrate the top layer of loose soil and compact the earth from the bottom up, kneading the clay. The danger of the antique toed models lay in a terrifying lack of control. They were essentially massive, free-rolling deadweights hooked behind a tractor. The most lethal scenario occurred on gradients. These heavy steel drums had no independent braking systems. If a tractor operator drove down a steep embankment or a hill, the weight of the roller, often filled with water or sand to increase mass, would overcome the friction of the tractor's tires. Physics would take over, and the roller would begin to push the tractor faster than its engine could turn. This frequently led to jackknifing, where the roller would push the rear of the tractor sideways, folding the combination in half. In the worst cases, the roller would override the hitch entirely, climbing up and over the tractor, crushing the operator under tons of steel knobs designed to pulverize earth. Even on flat ground, the feet presented a unique, gruesome hazard. Unlike a smooth drum roller that might push a fallen worker away, the sheep's foot roller was designed to grip and pull material underneath it. For ground crew working in the trenches, a slip near this moving machine meant getting caught by the lugs and dragged under the drum, leading to fatalities that were as horrific as they were instantaneous. 10. Draglines. The dragline. Excavator represents the absolute heavyweights of the earth-moving world. Used primarily in surface mining and massive civil engineering projects, these machines can be the size of small buildings. Unlike a hydraulic excavator, which uses a rigid steel arm to control the bucket with precision, the dragline operates on a system of cables, chains, and inertia. The bucket hangs freely from a long boom and is maneuvered by two main cables, the hoist rope, which lifts it, and the drag rope, which pulls it toward the machine. The danger of the dragline is the free-swinging load. The bucket, which alone can weigh between 40 to 100 tons empty, acts as a colossal wrecking ball. The operator does not have rigid control over the bucket's position once it starts swinging. To dig, the operator swings the entire housing and casts the bucket out, sometimes swinging it past the tip of the boom to gain extra reach. This requires impeccable timing. If the operator miscalculates the swing brake, the momentum of the massive bucket can cause it to crash into the boom structure, a catastrophic failure known as boom jacking, or smash into the machine's own housing. For support vehicles, the dragline is a nightmare. The operator is situated high up in a cab, often with limited visibility of the ground directly beneath the massive tub, the base the machine sits on. The bucket moves silently and swiftly through the air. There have been numerous incidents where dump trucks or bulldozers were struck by a swinging dragline bucket. Given the mass involved, a collision does not just damage the smaller vehicle, it obliterates it. Furthermore, the mechanical tension involved is astronomical. The steel cables are under hundreds of tons of tension. If a drag rope snaps, it recoils with enough energy to slice through steel supports, or the operator's cab like a hot knife through butter. Working around a dragline means working in the radius of a machine that relies on controlled chaos and massive kinetic energy to function. Surviving a shift on these machines required more than skill. It required cold courage. They are the monsters of the industrial world that separate the real operators from the steering wheel holders. If you understand the ground-shaking power of these beasts, you are in the right place.